G'day viewers, let's check the escape. I've already set it up, ready to go. Let's get to learn how to use it now. Brush up on the oscilloscoping skills. Let the CRT warm up. And there's my waveform at no load, just idle. If I open the fridge when the light turns on, looks alright. Doesn't seem very noisy. Looks like a good waveform to me. That's a very nice looking sine wave. It's definitely pure sine wave. Alright. Unplug the transformer. Obviously nothing. That's just what we're using for the reference for that. Because I can't put anything more than 100 volts through this. So obviously I'm using the transformer to step the voltage I'm testing down below 100 volts. I'm going to get a little double adapter here and I'm going to just so I can plug more things and load up the inverter and test it, how that looks at various loads, both for the resistive and inductive. Got rid of the awesome foursome. I wish they still made these. You can't get those anymore. These are only quality power boards you can get. As you can see, I've got plugged into the grid for reference. That's what the grid sine wave looks like. We've got a little bit of distortion there. It's a less headroom, so to speak. Because people have the grid's obviously being loaded and people are putting, got inverters from the solar and they're back feeding into the grid. And there's all sorts of other Chinese appliances and stuff in our electricity grid nowadays. With most crap in our infrastructure coming from China, yeah, you can't expect the grid to be most reliable now anyway. This little inverter for reference. Look how clean that is. There's a tiny bit of distortion here though. It's not bad. It's definitely pretty damn good for the price. A lot of the cheap inverters, the Spanning Swandler brand, and there's a cheaper version of this, there's actually got lots of noise, but this is actually pretty damn good. I'll turn the vacuum cleaner on. There's a bit of noise there. That's to be expected, but it's not bad. There's a bit of noise there. That's a 1000 watt load. That's actually a lot better than what I was expecting. That's actually pretty good. I'm happy with that. Let's try actually a polymer. That's a pretty heavy resistive load. This is a, what did I say it was last time? It's 1000 watts. Let's try a 1000 watt resistive load. Let's turn this polymer on. And the fridge just started up. I'm pulling 80 amps, resistive load, 1000 watts. That's pretty clear, a clean signal there. My scale lit up there. That's pretty good, I like that. Resistive load. Fridge running, that's an inductive load there on that compressor. Looking pretty good. Looking pretty damn good. I'm happy with that. That's pretty clean. A kettle will be the same sort of thing. Loading it up, and I did test this off camera before boiling a kettle a couple of times. It does it with ease. That was a 2.4 kilowatt rated kettle too. Yeah, that's pretty good. Happy with that. That's looking good. Oh, well, let's try my little 600 watt Mishto now, see how that performs. Again, I got the oscilloscope plugged into the grid, not into the inverter. Just in case you don't want to mess up your readings, in case this is putting that noise, so it's going to put noise into the scope and falsify your readings. So I'm happy with that. You can see here a little bit of distortion, a tiny bit, but it's definitely a lot less than I was expecting for an Edecoa inverter. As I said, these aren't known to be the best, but this particular one here is pretty damn good for what I paid for it. I'm happy with it so far. We're really just going to plug it in there, unplug, as you can see. Turn my mesh style inverter on. Fully charged batteries in there. See, it ramps up. Huh, not bad. Looking good. Let's fully load it with an inductive, like a vacuum cleaner. That was inductive as well for this one. So that's still a good test. Let's get a 600 watt vacuum cleaner and fully load that 600 watt inverter, which it does do it. It does run it. Let's run this 600 watt little handheld vacuum cleaner. Look at that waveform there. Plug this in. One hand, of course. Oh, let's look at the waveform. That's not bad at all. A slight drop in the voltage, of course. Not bad. Yeah, it kind of had a bit of noise as it started up because of the motor. I'm happy with that. That's awesome. Alright, let's my little heater. I can only run one element at a time though, this little heater. Otherwise it just overloads the inverter. 400 watt halogen heater. Let's try that little low resistive load on that mesh though. Oh, I hate it when that happens. Bloody plugs just get caught on everything. Ah well, it's only a cheap heater anyway. This thing's $20. It's $20 for a new set of bulbs for this thing. Plug it in. Oh, send it up. Turn 2 on. That's 800 watts there. Overloaded. That stayed like a pretty clean waveform throughout that whole test. Turn one off. That's fine. 400 watts. Turn it off. Yeah. I bumped it. I must have hit something there. I'm pretty happy with that. That looks like a bloody clean waveform. That's pretty good. Pretty damn good. I'm impressed. That's pretty good. I'm happy with that. That was better than what I expected to look at the output of this inverter. I'm happy with that. Pretty damn impressive. I'm impressed. Anyway, just one last check what the grid looks like. Of course, if I plug this into a computer UPS, you're going to get a square wave. Hell, I might just grab it. I'll go grab my UPS and I'll just show you that. How clean that looks, being a square wave. UPS on, turn the grid power off. You see there? There you go, it's a square wave. There's a little bit of distortion there. So, yeah. The UPS is a pretty dirty inverter inside those. Back on grid. The only design I stopped the computer from shutting down if there's an intermittent fail on the grid. This will provide power for up to half an hour with the original 7.2 amp hour battery, but I've upgraded to a CSP Hitachi 9 amp hour battery, so I get about 40 minutes of runtime on a power outage. But these are only, the inverters in those are only designed for switch mode power supplies, for something that takes the mains, chops it up, filters it, steps it down and rectifies it to DC. Things like switch mode power supplies, that's what they're designed for. Anything like fans, vacuum cleaners, inductive loads, forget it. They're not designed, they'll just plug in something like that and it would run hot over time. I'm pretty happy with that. Again, it's a square wave on a UPS set. You do get that when you plug in, I'll show you when I plug in this fan, you definitely hear the distortion and the motor just gets noisy when you plug one of these into it. You actually hear that noise coming through. The motor runs rough. It's not a good waveform for certain things. There you go, your square wave and your sine wave. And there we are. Anyway, let it be enough for now. Thanks for watching.